Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationct.com. In this film, we are talking about an example for minimum spanning tree. So let's move on.
Consider an example. In a building, there are 6 points that need to electrical wiring. The distance between these points are given in this matrix. The symbol infinity here represents the impossibility of the wiring between 2 points. By applying the minimum spanning tree algorithm, we can find the minimum wiring tree and determine the minimum amount of wire needed for connection for 6 points. In the first step, k is equal to 1, we need to choose the point arbitrary. Let's choose point 1, although any other point could be chosen. We create 1 times 6 matrix for this point as follows. In this matrix, the smallest number is equal to 1, which is marked with a square around it. This number represents the distance between point 1 to 2, indicating that the shortest distance to point 2 has been found is equal to 1. In the second stage, which is equal to 2, we add point 2, which had the shortest distance in the previous step, to the 1 times 6 matrix, and we now have a 2 times 6 matrix. Note that since points 1 and 2 has been assigned, we mark column 1 and 2 with the dash symbol, indicating that there is no need to check this point value. In this matrix, the smallest number is equal to 3, which represent the distance between point 2 to point 5. Therefore, we also have the shortest distance to point 5. So in the next step, which is k is equal to 3, we expand the matrix by adding row number 5. This results in a new 3 times 6 matrix. In the fourth step, we identify the smallest value in the matrix, which is equal to 4. This number represents the distance between point 2 and 4, okay? And we continue performing the same step for the next iteration. So we add the row number 4 in the step number 4. And minimum value of this matrix is equal to 3. So in the next iteration, we had to add row number 6. So this is a step 4, a step 5. And this is the final matrix. In this step, we observe that there are 3 numbers equal to 5, which are the smallest number in this matrix. As a result, the problem has a 3 solution. Since the shortest distance to all points has been obtained, so the algorithm concludes. The figure here shows the 3 solutions to the problem, which represent the minimum spanning tree for the example. And the length of the minimum spanning tree for these 3 solutions is equal to 16. Thank you so much for watching me. If you are any question and need any assistance, please do not hesitate to contact us by email or by filling the contact form in our website, which is www.optimizationcity.com. Thank you so much, and goodbye for now.